In this orthokeratology case, we have a patient who's getting uncorrected cylinder coming through after lens wear. Both eyes are using a lens with an oval and toric treatment zone, but we're seeing fairly spherical treatment zones in both eyes. And especially in the left eye, we can see an against the rule bow tie pattern, which is translating into cylindrical post-wear refraction and reduced acuity. If we look at the fluorescein pattern, we can see some bubbles superiorly and inferiorly in the right eye, and then more so, especially superiorly in the left eye. And now looking at the lenses that the patient's wearing, we can see why there are bubbles. We have quite a bit of clearance, close to 90 microns in the right eye, and then a little bit more than 90 microns at the peak of the reverse zone in the left eye. So up around that amount of clearance, it's very likely that we'll see bubbles, and bubbles aren't always a problem, but in this case it does seem like the patient's not getting enough molding in the vertical meridian. So if we want to decrease the maximum clearance underneath the lens while maintaining the same topo demand, the only way to do that are to either reduce the OZ size or to add asphericity. And in this case, in the vertical meridian, we're already working pretty small. I think we're 5.6 and 6.2. And in order to get a 15 to 20 micron drop in maximum clearance, we would probably have to make the OZ a little bit too small of an OZ, even in kids, causes them to not get very good acuity because we get too much plus from the reverse curve within the pupil. So I think in this case I would consider adding some asphericity to the lens. I'll work on the left lens since we have more clearance on that side. On the left side here, I created a new lens for the left eye. Here's the current lens for the left eye. This is what I did is added in plus 20 shape factor, and then I decreased the clearance until the topo demand for the new lens matched the topo demand of the current lens. The power and the base curve are going to look different because we have the central asphericity. And then in 25% mode, you have to go back and forth between the meridians because when you make the adjustment, you'll have quite a bit of disparity between power temporal side of the lens versus nasal side of the lens. So in 25% mode, you just have to adjust the topo demand up and down until you get fairly equivalent powers in 180 degrees away from each other. So superior and inferior, and then the obliques should be fairly symmetrical. That's just a lot of up and down and clicking around the meridians until you have powers that are fairly even across on the mirrored side of the lens, and then also a demand that matches your original. So if we go back to the superior meridian, we can see we still have a lot of clearance. We're up at around 85 microns. We dropped maybe close to 10 microns, and this may be enough, this may not be. I have a feeling you're still going to see bubbles even with this reduced clearance. Another option would be to go to a semiscleral lens and have the patient fill the lens bowl with inhalation solution or non-preserved tears prior to application to get rid of the bubbles. Even without bubbles, though, we can get to a point where there's so much clearance that the fluid gradient is not strong enough to distribute forces evenly. So where we have excessive clearance, we get less molding. In this case, it'll be the vertical meridian where we are trying to get more molding. But without going to a semiscleral, this is probably the next lens change I would make. To add to this, you can perhaps make the OZ and IC a little bit smaller. Maybe that'll help us drop the maximum clearance another 5 microns or so. And hopefully that will take care of the cylinder that is residual in the patient's refraction. So hopefully this is helpful. Best of luck with your patient, and thanks for watching.